Okay, so what we're going to look at is a review sheet for the quiz on Tuesday on fundamental counting principle, permutations, combinations, the theoretical probability, which is mainly just independent versus dependent, and then our conditional property. I'm really just going to be focusing on the two-way tables. So the first thing I wanted to do was just start with a few definitions or formulas to kind of refresh our memory on how to do mainly the earlier stuff. The fundamental counting principle, we just kind of multiply all the different possibilities. So you just multiply m times n. For a permutation, that's an arrangement where order matters. We're just going to use a Desmo scientific calculator if your calculator doesn't have that button, and we're not going to go over the factorials again now that we're here. Combination is an arrangement where order doesn't matter, and we'll go over how to do that in the calculator. Just as a refresher, N is a total number of items, and R is how many you're focusing on. So if we were doing a permutation and there was 20 people and we wanted to know how many people could get president, vice president, or treasurer, it would be 20p3. But we'll go over that in the different practice problems. An independent event, that's where the outcome does not affect the outcome of another. So we just take the probability of A and times it by the probability of B. Think two things aren't connected, you're rolling a die and picking a card, or if you are picking two cards, you replace it. Dependent is when the outcome of an event does not affect the outcome, when the outcome of an event does affect the outcome of another. So you do the probability of A and then the probability of B after A has occurred. So think that we have two cards and we don't replace it. And then our last thing, the conditional probability, we're going to be focusing just on the two-way tables, but we do the probability of A and B over that probability of A with the given B given A type of deal that we went over last video. So the first topic, we're going to focus in on the fundamental counting principle, permutations, and combinations. So in problem number 1, the library labels each book with a 5-digit code to identify the book in their computer system. Each code is 3 digits, 0 through 9, followed by 2 letters. How many codes are possible? So we have 3 digits, 0 through 9, so that's 10 possibilities, followed by 2 letters. There's 26 letters in the alphabet. We have a total of 5 digits. So the first 3 digits of that code are going to be tens because the 10 digits, 10 times 10 times 10. And then the next 2 digits in the code are going to be 26 because there's 26 letters in the alphabet. So times 26 times 26. We multiply all of those together and we get 676,000. So you're going to try these next two on your own. Mrs. Manning went shopping and purchased 5 shirts, 3 pairs of pants, and 4 jackets. How many different outfits are possible? So hopefully we just did 5 times 3 times 4 and got a possible 60 combinations. And in problem number 3, Nike's custom shoes offers 10 different color choices for the shoe, 7 different colors for the swoosh, 5 different colors for the laces, and 4 colors for the midsole. How many options are possible? So hopefully you just did 10 times 7 times 5 times 4 and got a total of 1,400. Okay, let's look at permutations and combinations. So in here, we see that Sean must answer 3 out of 8 essay questions on his writing test. How many ways can he choose 3? So here, order doesn't matter. He knows all of them about the same amount of way. So it's going to be a combination. So we're going to do 8, choose 3 in our calculator. So on the Desmos calculator, you can just Google Desmo Scientific. I'm going to make this bigger. You're going to go, you show it up with the main. Go over to function, and you see here we have our combination and our permutation. You hit N, choose R, and then it's going to come up with the parentheses. You plug in 8, 3, and then you'll get the answer of 56. So if there's any issues for that, please reach out. But you go to Desmo Scientific. Here we're doing a combination, so you click that button, and then you do parentheses. I think it already might come up, 8, 3, and then hit enter. Okay, let's try another one. In problem number 5, how many ways can a president, vice president, and a treasurer be elected from a group of 40 students? So here, order matters, so it's going to be a permutation. So a permutation, so 40 total, we want to know permutation 3. So once again, in my calculator, the Desmo Scientific, I hit the permutation under function, and then 40, 3, and I get my answer 59,280. So you're going to try the next two and see how we do. So on problem number 6, let's see how we did. The field hockey coach chooses players to put away equipment after each practice. If there are 16 players on the team, how many ways can she choose 5? So here, order doesn't matter. We have a combination. So 16 choose 5, I got 4,368. In problem number 7, let's see how we did. A coach needs to choose 2 players from the field hockey team to be captain and assistant captain. So now, order is going to matter. If there's 20 players on the team, how many ways can the coach assign the 2 roles? So here's going to be a permutation. So 20 permutation 2 in our calculator, we should get 380. So I know before when we did this lesson in class, we did the formula out with the factorials, those exclamation points. We're just going to do it in our calculator from now. So topic number 2, the theoretical probability and our independent versus dependent events. So problem number 8. Katie is randomly choosing a date in the month of August. There's 31 days in August. What is the probability that she chooses a 2-digit number or a prime number? So what I did is I wrote all the 2-digit numbers out and then all the prime numbers out. I counted all of them. That's a total of 26 total numbers right here. There's 31 days in August, so that probability is 26 over 31. I'm going to have you guys try the next one. In problem number 9, let's see how we did. John's wallet contains 6 $1 bills, 4 $5 bills, 2 $10 bills, and 3 $20 bills. If John randomly removes a bill, what is the probability that it is at least $5? So first thing we have to do is add up 6 plus 4 plus 2 plus 3, and there's a total of 15 total bills in the wallet. We want to know the probability that there's at least $5. So you can say 15 minus 6, because everything else would be greater than 5. So hopefully we got 9 over 15. We always want to put everything in simplest form, so 3 over 5. Okay, let's look at independent and dependent. Remember, independent is when we replace it. Dependent is when we don't replace it. So questions 10 and 11 are going to be independent. A bag contains 25 red chips, 18 blue chips, and 29 yellow chips. A chip is selected, replaced, and another chip is chosen. Find each probability. So in problem number 10, we need to find the probability that we pick a blue and then a red. So first step, how many total? 25 plus 18 plus 29 got me a total of 72. So what's the probability of choosing a blue chip? Well, that would be 18 over 72. We're replacing it, so there's still 72 chips in our bag. What's the probability of choosing a red? That would be 25 over 72. Multiply them together, I got 450 over 5,184. Put it in simplest terms, so I got 25 over 288. So I'm going to have you try the next one and see how we do. Okay, let's check number 11. The probability of getting a yellow and then a blue. So the probability of getting a yellow, 29 over 72. Probability of getting a blue, 18 over 72. Multiply them together, we get this really big fraction, 522 over 5,184, which we simplify to 29 over 288. Okay, let's move on to our last page, which is going to look at 12 and 13 are going to be dependent, because here we have a box of pizza. Pizza contains 3 cheese slices, 7 pepperoni slices, and 5 supreme slices. Mark randomly chooses a slice, eats it, and then chooses another. Find each probability. So we know this is dependent because we're not replacing the pizza. He ate it. So let's look at 12 together. What's the probability that you have cheese and then supreme? So how many total things do we have first? That's always should be our starting point. We have a total slices 15. So what's the probability of getting cheese? So that would be 3 over 15. But now there's going to be 14 slices of pizza. So how many? 5 over 14. Multiply them together. 15 over 210. If we simplify that, we should get 1 over 14. So I'm going to have you guys try number 13, and then we'll check it. So let's see how we did on problem number 13. Probability of getting 2 pepperonis. So there's 7 pepperoni slices, still 15. But now, what's the probability of getting another pepperoni? That would be 6 over 14. Multiply them together, we get 30. That'd be 42. Sorry. 42 over 210. And then that should, I think, simplify still to 1/5. So the 1/5 is correct. That should be 42. My bad. Okay. Our last topic is the conditional probability, the two-way table. So this is mainly what we're going to focus on. So in 14, a group of cell phone owners were asked whether they had an Android or an Apple phone. Use the results from the table to find each probability. So first thing I did, I found the total number of each column and then the total of 125. That line in B and C, that means that's a given. So in part A, it's just what's the probability that there's a male and he owns an Android. So that probability would just be 34 over 125. Let's look at part B. What's the probability that we have the Apple given? We have a male, so the Apple male is 30 over the male. Think of that almost like the fraction. Over how many males are there? 64. So 30 over 64, which will simplify to 15 over 32. So think we want that combination Apple and their male over the male. That's it. So I'm going to have you try C and we'll check it. So let's see how we did. Probability a female given they have an Android. So where's that combination? Where they overlap, female Android is 19. How many people have Androids total? 53. So this should be 19 over 53. So if there's any questions, please let me know. We'll do a little kind of review before Tuesday's quiz, which will just be a Canvas quiz, and we'll go from there.